Hello, this is Mahendra Didia. The book on liquid formulation utilizes video formats. This is Module 5 on preformulation studies that are used in solution formulation development. This is the second related video with focus on stability, kinetics, and compatibility. Reader is requested to refer to video in submodule 2.3 for reaction order and shelf life determination. The focus of this submodule is studies performed at pre-formulation level, includes assay development of the drug substance or active and functional excipient. The methods include HPLC, mass spec, DSC, FTIR, solid state NMR, thermal activity monitoring, XRD. Methods used in preformulation study should be specific and should be able to separate similar molecule. That is, it should be stability indicating. Here's an example. Here's the method, reverse phase HPLC, used to separate triacylglycerol that are contained in rapeseed oil. The molecular structure of triacylglycerols is shown here with groups R1, R2, and R3. R1 and R2 and R3 can be either palmitate, stearate, oleate, linoate, or triene linoates. And the method here used shows the separation of triglycerols from LLT, that means linoate, and triene. So this peak here represents that. Similarly, OTT, oleate, triene. So this would be oleate group, R2, R3 being triene groups is shown here. And this HPLC, with its runtime of 75 minutes, is able to separate different components of triacylglycerol. So one can use this type of method in preformulation. Preformulation also deals with solid state characterization of solutes. Solutes property affects the bulk properties such as density, viscosity, stability of liquid products, solution characterization, and crystalline form affect the solution, clinical bioavailability. In addition to that, particle size studied as part of preformulation, and this was covered in module 5.1. Hygroscopic material, the material that pick moisture upon exposure, require low humidity processing, specifically during weighing and transferring. Here are the examples of polymorph and effects on solubility. Paracetamol has two forms. In solubility, there is slight difference. Chloramphenicol, there are two forms. Solubilities are very different throughout the temperature range. One has to be aware of it, that it can convert from form alpha to form beta. Sulfathazole has several forms, form 3 and 4. Solubility is not significantly different. Preformulation stability storage conditions are different than those are used in a product according to the regulatory guidelines. Preformulation studies are conducted at a different temperature and storage condition. Reader is requested to refer to videos in submodule 2.3 for reaction order and shelf life determination. The temperature from minus 70 degrees all the way to a very high temperature of about 121 degrees can be used in preformulation studies. Freeze-thaw cycle, which are very common, 3 cycles up to 48 hours, is used to see the precipitation or changes of polymorphs. Humidities are used at different levels. For example, 40 degrees, high and low humidities will be studied. Low humidity because things will evaporate at low humidity. Same thing at 50 degrees. Low and high humidity will be used. 121 degrees, solutions that are used for intravenous or injectable formulations have to be studied to see the effect of temperature and time under closed conditions. In preformulation studies, opened and closed container systems are used, beaker or petri dish, as well as closed bottles. Preformulation ingredient compatibility, or active and excipient may interact, and that would affect its chemical, physical, and bioavailability and pharmacological properties and stability of it. Physical incompatibilities, change in forms, color, taste, solubility, liquefaction, immiscibility, separations that can happen if the excipient is not compatible with the active solute. Chemical incompatibility involves reactions between active, solute, and the excipient under stress conditions shown before, such as 50 degrees, 60 degrees, 40 degrees, predict hydrolysis, oxidation, reduction, precipitation, decarboxylation, and understand the drug degradation path. Biopharmaceutical changes due to precipitation of insoluble polymorph, presence of toxic impurities. We'll look at aspirin compatibility composition. Lipid solution of ASA, commonly known as aspirin. ASA aspirin is very stable in solid dry form. It hydrolyzes when it's exposed to water, humidity conditions, leading into formation in forms acetic acid and salicylic acid. In this study, 32.5% of ASA and 4 lipids were looked at. Lipid formulation, gel oil, composition is shown here. Geliol, it's a mono and diglycerides. Labrafat, medium chain triglycerides. And mesine, which is glycerol monoleonate. In 2 cases, heat was applied to melt the excipients. The compatibility studies conducted in open dish, 250 ml glass beaker at 40 degrees 75% humidity. When neat ASA is stored in a dry condition, it does not degrade, it does not form salicylic acid. When it's stored in open dish container, all 3 different solvents show degradation, is least in gel oil. So this type of information is now helpful, that is to rule out use of Labrafat gel oil or mesine gel oil formula and focus on gel oil for further development. Thermoactive monitoring, TAM, colorimetric, measures the interaction energy, joules per gram, and it shows that gel oil has the least interaction energy when the product is stored at 40 degrees in glass ampoules. So these studies are short duration studies. We'll look at another case study, captopril compatibility compositions. Captopril is susceptible to oxidation, and it is influenced by high humidity and catalyzed by metal traces presence in excipient. So we can arrest the metal traces by chelating agents such as EDTA. Composition involves different concentration of EDTA, 0.05, 0.1. Different types of water used. Distilled water and mineral water obviously contains traces amount of metals. pH range from 2.5, 4, and 5.5 in each cases. And sucralose sweetener was added at range between 0.2 to 0.15. Captopril converts to captopril disulfide. This study was conducted at a high temperature, 60 degrees, for 12-day period. In the graph, control shown as a black square, shows degradation more than 10%. Different formulation compositions are shown, and the most promising is formulation FE, shown here as olive green triangle. Contains 0.1% EDTA and pH of 4 in distilled water, and sucralose is added to assure that the compatibility is done with a sweetener. Further detail to see interaction between EDTA and pH. pH and captopril in water is analyzed using distilled water, shows decrease of captopril to 80% at pH 2.5 and greater at pH 5.5 with 0.005% EDTA. Similar information in mineral water. EDTA at 0.08% and pH of 3.85. That's the most protective. In real practice, pH of 4 and EDTA 0.1% will provide most protection. This type of information on compatibility comes from preformulation and provided formulation. Organoleptic property or sensory property for cosmetics. Organoleptic property require flavors, sweeteners, colors based on the taste of drug substance or functional excipient, their physical appearance. FDA looks at organoleptic property as one of the QBD quality by design criteria for oral solution. Preformulation study drug and excipient that come in contact with taste bud as bitter, sour, sweet, etc. Similarly, in cosmetic and dermatological product, there is a sensory effect. Drug and excipient that come in contact with skins have odors, pungent, sweet, fruity, decayed, etc. These type of terminology are used so convert this type of terminology to describe the same property, defining the standard terminologies. Preformulation studies focus on stability, compatibility, and include organoleptic properties.